on covalent bonding. Covalent bonding occurs when nonmetals bond with nonmetals. And in covalent bonding, electrons are not lost or gained, they are shared. Sharing of electrons. Okay? So let's have a look at some examples. Here's a simple example. Hydrogen. Hydrogen exists as H2. This is because one hydrogen atom has one electron in its outer shell. Why? Because it's atomic number 1. It has one electron. The first shell is filled with 2 electrons. So hydrogen, another hydrogen atom can come along and share like so. These 2 electrons are a shared pair of electrons, and this shared pair of electrons is known as a covalent bond. In this case, a single covalent bond, because there's only one pair between the 2 of them. Notice that round about both shells there are 2 electrons. We show the single covalent bond as a stick like so, and that the molecular formula is H2. Okay? Okay, let's do some slightly harder ones. Nitrogen. Well, nitrogen has got some group 5, its atomic number 7, so that means its electronic structure is 2,5. Because of that, it has 5 electrons in its outer shell. It needs 8. So along comes another nitrogen atom, and it also has 5 electrons in its outer shell. Okay, so round about the nitrogen, this nitrogen shell, you can see 1, 2, 3, 4, 5, 6, 7, 8 electrons. And round about this nitrogen here, 1, 2, 3, 4, 5, 6, 7, 8 electrons. Both of them, therefore, have got 8 electrons in the outer shell. Now this is known as a triple covalent bond, because this time 3 pairs of electrons are shared between each nitrogen. Okay? Now this whole thing is a little bit messy. You wouldn't be writing that down. That's just me trying to emphasize it. When you write it down, remember 1, 2, 3, 4, 5. And round about this nitrogen here. 1, 2, 3, 4, 5. So there's 8 between both. Cool? So nitrogen is N2 because there are 2 nitrogens in the molecule. Here's another nitrogen molecule, ammonia. Ammonia is when nitrogen bonds with hydrogen. Now 3 hydrogens will bond with 1 nitrogen. That's because nitrogen needs 3 because it already has 5. With 1 more hydrogen, one hydrogen will provide 1 electron each. Now look, round about okay, the nitrogen, you have 1, 2, 3, 4, 5, 6, 7, 8 electrons. And round about the hydrogens, each hydrogen has 2. So they're both half-A, because remember, hydrogen, the first shell only contains 2. So it looks like this. One, two, three bonds. All right. How about another example? This time we're going to look at methane. And methane is CH4. Carbons in group 4. 1, 2, 3, 4. Therefore, it will need to share with 4 separate hydrogens because each one of them will provide 1 electron. How many electrons are round about the carbon atoms? 1, 2, 3, 4, 5, 6, 7, 8. And the hydrogens have 2 in each one. So you end up with this structure. Now this is a 2-dimensional shape. The 3-dimensional shape looks like this. And this is called tetrahedral. Okay? Let's do one more example. Water. Okay? Water is H2O. Oxygen is in group 6. That means it has 6 electrons in its outer shell. It needs to share 2 more. Therefore, with hydrogen, it will get 1 electron. Round about the oxygen, we have 2, 4, 6, and 8. And round about the hydrogen, we have 2 each time. So both of these are very intense, and the shape is like this. This is bent. Okay? So I think that's all for this little part. Oh, why don't we do one more? Yeah, why not? Okay, carbon tetrachloride, CCl4. 1, 2, 3, 4. Carbon is in group 4. Chlorine, 1, 2, 3, 4. Chlorine's in group 7. So, 7 electrons round about for every chlorine. Now, you have to show this for all of them. Don't be lazy, folks. Put them all in. And you should be able to see that round about every chlorine, there are 1, 2, 3, 4, 5, 6, 7, 8. Each chlorine has 8. Each chlorine has 8. But each carbon, or the carbon, has 1, 2, 3, 4, 5, 6, 7, 8. So it's 2-dimensional structure. Ooh, not hydrogen, but chlorine. The 2-dimensional structure looks like this, and that will also be a tetrahedron. Okay, so that's definitely the end of this little podcast on covalent bonding. Cheers!